Hello, and welcome to the Mr. 50mm YouTube channel. This is part two of the cheapest digital rangefinder build. If you haven't watched part 1, that'll be linked in the description below. Maybe it'll be on a card above if I can figure that stuff out. Last time we talked about the concept of the camera and I showed it off a bit. In this video, we're going to talk about what works, what are the quirks, and what I think still needs to be done for this camera. Let's get into it. What works? In the last video, I did state this camera functions, and that's very true. At the moment, the camera's rangefinder is properly focusing with the Voigtlander lens on it. It's pretty accurate up till around 1 meter, and then anything less than that does require some stopping down to kind of hit the right focus. However, from what I understand about this rangefinder design, this is mostly due to the fact that these rangefinders weren't designed to really focus that much closer than 1 meter, since they're inspired a little bit by the Leica 3 series. And the camera's finder on this particular camera was simply taken out of the Fed 5C and reinstalled on this body. No mods were done to it. The placement of the finder was copied as closely as possible to the 5C original placement, and I tried to accommodate the placement of the finder with the placement of the sensor and shutter from the GF3 respectively. Because the sensor and shutter were actually from my TLR design, I did actually end up having to adjust a bit of the placements of these from the original placement of the rangefinder, just to, one, have the rangefinder sit properly, and two, make sure it had enough space for the rangefinder cam arm to move properly. Additionally, the GF3 bits all work. I didn't really have to omit anything, as you can see all the buttons were ported to the back of the camera or the top of the camera. The only thing that I didn't include was the IA mode change button, because I think it's stupid. I did think it was stupid on the GF3, and I think it's double stupid on a rangefinder. So that is not ported over. Additionally, touchscreen on the GF3 functions just fine. So that's pretty neat. And the microphone has been retained, and it's right here. I don't know if you can see it. So video mode does still function, and it will record sound. And I remembered to keep the clock battery connected to the main board, so I don't have to be constantly annoyed by the time resetting. Two things though that I did change from the GF3 is I removed the GF3's little speaker, so there's no more sound, and I removed the little front LED that was on the GF3, so that's, it's gone. And because one of my goals was to keep as many parts of the GF3 as original as possible, the original battery is still being used, the contacts for that are still being used, SD card slot hasn't been shifted around or anything, and nothing on any of the PCBs or main boards were augmented, really. Alright, so this segment is definitely a little bit more of a recap of the previous video, so let's move on to the next part. The quirks. So one thing I mentioned about this camera was that the original mounting system for the camera shutter and sensor were heavily based off of the digital TLR design that I used. And I did this to save time since I knew I'd have to remount the shutter and sensor anyways. One thing that I didn't actually notice from that were, well, more than one thing, but a couple things, were that the way that the sensor and the shutter was mounted wasn't correct. The way that so let's back up here. So when I did the design, I basically reverse engineered the mounts using a bit of a janky old school methodology. Essentially, I took the part out. I used a pen and paper to trace the components, and I used a cheap set of digital calipers to do a bunch of measurements, that kind of thing. I don't have a 3D scanner, so I can't just scan it and have a look at a model and be ready to go. This actually resulted in me making a couple assumptions about my measurements and placements that were wrong. The sensor mount is probably the best example of this. Looking closely at one of my first prints using my TLR sensor and shutter placement, I quickly learned that things were a bit askew. This was especially true when I had my first shooting prototype. I noticed that more than a few shots were not level. I initially chalked this up to me getting readjusted to rangefinders, because that is a thing, for me anyways. However, I eventually put the camera on a flat surface and pointed it out to the horizon. And that's when I noticed, while the camera looked flat, the image did not. So this actually took me several revisions to mostly correct. I believe that there's still a very tiny amount of askewedness. On a related note, the sensor in this camera is not perfectly centered. The framing is mostly centered when it comes to left and right, but the top and bottom are a bit off. The sensor is a little bit lower than center frame. And this is fortunately not due to me being bad at measuring things. This is due to interference from the rangefinder with the sensor mounting bracket. The sensor mount itself extends above the actual sensor, and physically there is very little space between where that sensor mount is and where the rangefinder frame sits. Initially, the sensor was actually a little more centered, but that's when I noticed that the rangefinder was being pushed up at an angle and it was not level with the camera. And for that particular version of the camera, I had to raise the entire RF module up a little bit to get it at least kind of level. You may have noticed on the previous video, one of the 3D prints I held up had globs of glue on that. That was partly to keep the back of that rangefinder up and level. So this resulted in me adjusting the 3D model so that, yeah, the rangefinder module would not touch the top of the sensor mount. And it's these two quirks, the slight askewedness of the sensor and the off-centeredness of it, result in the rangefinder being also a bit off. Again, honestly though, you kind of get used to it after a couple days, but initially it does feel weird when you look through the finder and you think that the center of the focusing patch is generally the center of the frame, and you take the shot, you will see that it is not. It's just something that you kind of just have to get used to. I think this is actually a little better if you use a more, like a longer lens, but for me, using a wider 56 millimeter equivalent lens, a considerable amount of the viewfinder is, broadly covered by that, and as a result, there are like parts of it that are, the up and down bits, the horizon and the ground, they're not exactly where I think they are, or at least they weren't until I got used to it. This effectively makes the rangefinder more a general guide rather than a hard and fast, accurate representation of the frame. And in this regard, the Soviet era finder that I use kind of works, since this thing doesn't have projected frame lines anyways. So looking through it, you're not getting, you know, any great indications of generally where your framing is. And in case you're still not aware, the back of the camera is a Panasonic GF3. This is a camera that does not have an EVF. So the rear screen of this camera always stays on. Not only that, the touch interface is generally active. You can disable stuff and you can stop some unintentional touches, but there's a couple things I left on just to make it a little easier anyways. But what this results in is, you know, when you're using the camera with the finder up your face, you tend to nose touch things. The result of this is that, you know, I have this little magnetically connected thing here that covers up the rear screen as to not always be poking the touch screen. You may have also noticed that on this camera there's no built-in flash, although there was one on the GF3. For me, I personally don't think it's a huge deal, but I do understand the want for a flash. So I am considering seeing whether or not I can convert one of the connections on the GF3's board to trigger either a PC, to act as either a PC sync trigger or a hot shoe trigger. I feel like I can kind of do it based on the connections that are on there. Pretty sure I can figure out which one is one that triggers the flash, but we'll see. The last two things that I think are interesting quirks are the SD card and the battery latch. Removing the SD card slot is actually hilarious. You actually need to use some sort of tool. I normally would use a set of tweezers, but like something like a screwdriver will also work because you physically there's no space to press that SD card slot eject. But I realized writing this script, looking at the way I designed this battery door or battery latch, I can just, you know, cut a hole in this design, and that should give me enough space to press the SD card slot and get it to eject without tweezers. The other thing about the battery door is that, again, in this current configuration, and probably in most of them, because of the way that this latch pushes up this way, the SD card must be removed before you can remove the battery. So that's also a weird quirk. What are the bigger things that need doing? So this camera does have other bigger issues, things that I wouldn't call quirks, or just things that I generally would want to implement, just things that I think pretty much need to be done. And part of that is, you know, I did this design in quite a haste. One of the things I forgot to do was to model proper standoffs for the GF3 main board. At the moment, 2 standoffs have been modeled and tested and appear to work pretty well. One is still not really a thing. It is a bit awkward, and so at the moment, one of the ends of the motherboard is kind of just floating because there's no screw to hold it down. This particular one is around this area, just happens to be where the sensor is, or the shutter is, or where the rangefinder stuff is. So just a bit awkward to figure out how to make a standoff for a screw to attach to the actual plastic casing. But I'm probably going to test it for now with just using the 2 standoffs that are on this side and see how well that works. Since previous to me doing that, as I mentioned, there were no standoffs. And so the main board was literally just being supported by flat flex cables. Pretty terrible. Another thing that is a bit of a problem is that you may have noticed that I keep saying that I'm using this with a Voigtlander 28mm f1.9. Not only that, I keep saying specifically that the finder is, you know, accurately working with just the 28mm f1.9. And that's because there is a slight issue. So this camera does indeed use a Leica thread mount. But it seems that my design it means that the coupling is not perfect. When switching lenses, the rangefinder seems to lose calibration based on what lens I've switched to. At the moment, I'm pretty sure it's because of slight issues with the flatness of the rangefinder module. I think it's a little bit off. This results in the cam here being at a slight angle. And so when I swap lenses to a lens that has a helicoil that is placed in a slightly different position, the way that it interfaces with the lens and the camera body mean that it's touching at a slightly different position than it should be, and so we have a minor offset. This is actually pretty annoying if you want to do really quick lens swaps, since essentially whenever you switch lenses, you have to recalibrate the finder using a little porthole under here to set your rangefinder calibration to make sure it's correct. Luckily for a digital rangefinder, it's actually a pretty trivial thing. Essentially, you switch your lens, grab a tiny screwdriver, pull open this flap, and then set your focusing to infinity on live view, and then adjust the finder to match that, and generally you're good to go. But I admit, that's not a fun process, doesn't make it a nice interchangeable, like a rapid interchangeable system, and I'm really hoping that by the next revision or two that I'll have this problem solved and you can, freely swap lenses without having to recalibrate every single time. Additionally, this camera has, I believe, some light leaks. There's still some sealing to be done. For the most part, it actually is pretty good. I didn't notice too much light leaks, especially given all the leather repair that I've jammed on this camera. But once in a while, in some instances, I did notice a minor light leak. So there's still things to tape up, things to seal. I suspect quite a bit of that is the bottom of the camera here. The section where the SD card is quite exposed, and with enough light, I'm sure it will make it to the sensor. Lastly, because the goal of this camera is to make things accessible eventually, I've still basically got to generate documentation. I've still got to decide what parts to release and, to provide a guide of sorts. Luckily, I've been building up a folder of the most current parts and the variations of the parts I think work best, and so I've got a bit of a handle on that. Additionally, I've also got a general idea of what's the best way to print them on at least a conventional FDM 3D pooper printer. So what's left is getting things written down, recording some videos, and generally putting together a proper guide on how to assemble one of these things. That being said, I do assume that with this particular project, things will probably keep changing and there'll be a little bit of tweaking throughout a couple variations, but all in all, I think I can generally get a relatively comprehensive guide for how to assemble these out at one point or another. At any rate, that's all I got for this video, but here's the question I have for you. Is there anything that you think I should address or anything that I should add to this build? Let me know in the comments below. Otherwise, don't forget to like, comment, and subscribe. Maybe a super thanks if you're into that. Till next time, bye.